example, batteries to store electricity, as well as, for example, carbon neutral or carbon free energy carriers, such as hydrogen, such as the hydrocarbon generated through renewables, so that we can actually provide combined heat and electricity to meet our demands in buildings, as well as for decarbonization of our industrial process. Think about metal making or steel making. Think about cement. Making cement currently contribute significant fraction of our CO2 emission, roughly 4%. In addition, ammonia, really key chemical or ingredient for making fertilizers, that contributes to 1% or 1.4% of our CO2 emission. And these processes essentially require heat. And that heat is provided through hydrocarbon, right? Burning of hydrocarbon generate heat. Alternative way we can think about, we generate hydrocarbon or generate heat source that coming from essentially energy carriers, right? Made through renewables. Right? For example, we can make hydrogen, we can make hydrocarbon, we can make, for example, ammonia utilizing electricity. Right? So these are really challenges and opportunities. We can essentially utilize electrons in the electrolytic cells to generate these carriers so that they can be essentially renewable instead of, for example, utilizing fossil fuel, which is not renewable. Some of these processes, like cement making, naturally generate CO2. So therefore, it's very important to develop also negative emission technologies combined with, for example, these technologies such as aviation. If you utilize, for example, hydrocarbon generated through renewables to capture the CO2, right, to reduce our CO2 emission, which is needed in order to slow down, reduce our CO2 emission and slow down the global temperature rise. So if you think about what's the difference, among different technologies, so I have listed, you have batteries, you have electrolytic cells, you have fuel cells. So what's really the difference, right? So we think about, batteries poised to power electrified light-duty vehicles. We might utilize combination of batteries and fuel cells to power aviation, to power heavy-duty vehicles. Really, what's the difference? Right? So if you think about the difference, is that lithium-ion batteries are a closed system. So currently, we can typically not decouple power and energy when we design the system. So the net result is the capital cost of such a system will remain flat as you scale the size of system. Right? On the other hand, if you look at fuel cells or electrolytic cells, we can decouple power and energy. So therefore, if we build very large system, right? So if you want to have, hydrogen as your energy source for various storage purposes over a course of, you want the energy to be stored, for example, for 2 weeks, for a month or a few months, then the system, the fuel, or hydrogen as fuel or hydrogen or energy carriers containing hydrogen made through electrolytic cells can be much lower in cost, right? The larger system relative to lithium-ion batteries. And so if you think about flow batteries, operate in between or analogous to fuel cells or analogous to electrolytic cells, because they are open system, we can decouple energy and the power. And this is why lithium-ion batteries, a closed system, right now are poised to electrify light-duty vehicles, and where a hybrid system utilizing energy carriers such as hydrogen are poised to electrify aviation, heavy-duty vehicles, buildings, as well as our industrial process. And due to its nature of decoupling power and energy to bring down the cost of the stored electricity in the form of energy carrier. So now what we want to focus on is some of the opportunities and the challenges in electrifying and generating the energy carrier. So we can think about electrons or electricity come from renewables, right? We want to store the electrons in chemical form. So we can store the electrons by electrify water, by water splitting, and generate energy carriers such as hydrogen. Analogously, we can reduce CO2, nitrogen, to generate energy carriers such as hydrocarbon containing molecules or ammonia, where we can also think of reducing metal oxide, right? Electrolytically to generate metal is also a process of energy storage. Right? So now, instead of doing mining thermochemically using heat to reduce metal oxide to generate metal, we envision a future that we do mining electrochemically. We're using electrons to reduce metal oxide to generate metal, right? To significantly decarbonize our mining or industrial process. So once we have the energy carriers, we can combine them with oxygen to either in batteries or in fuel cells to generate electricity and reform these molecules or metal oxide are stable under our ambient conditions and generate electricity to meet various demand. Now, this energy cycle, we want it to be very efficient. So on the left-hand side, we have energy storage, right? So we want stored electrons in chemical form to generate energy carriers on the bottom, right? On the right-hand side is energy generation. Essentially, we'll convert the chemical energy to electric energy. So we want the process to be as efficient as possible. Unfortunately, due to the slow kinetics of many reactions, for example, the oxidation water to evolve oxygen, and this is very slow, has a very slow reaction kinetics, as well as a reduction of CO2 to generate hydrocarbon molecules, or as well as reduction of nitrogen to generate ammonia, right? And these essentially challenging reaction kinetics limit the efficiency of the overall process for the energy conversion, right? So for example, lithium-ion batteries, we're looking at energy round-trip efficiency of 90% on the system level. And for our fuel cell, electrolytic cell, the overall cycle is on the order of 50, 60%. Right? So this is really the challenge if you want to utilize such a technology for deep carbonization in our buildings, in our industrial process. We need to figure out how to essentially enhance the rate of the reaction so we make essentially the process more efficient, right? So if we can make the process more efficient, essentially we lose less of energy each time. We convert, we store, and we generate electricity. And so this is where we want to think about how we can design catalysts, right? The surfaces or molecular catalysts that can enhance the rate of reactions. So catalysts function by interacting with the molecules you want to catalyze and generate reaction intermediates so that a barrier, for example, from the reactant to product can be reduced. And this is the area that we'll work on. And I want to show you a series of reactions that we've been working on recently, really thinking from the oxide electronic structure perspective, right? So we don't want to think about catalyzing different reactions discretely, but rather than think about how we can develop a universal thinking, right? So think about from the electronic structure of oxide, particularly the valence band of oxides. Right? What are the unique features that we can actually think about that will correlate with catalytic activity, and we utilize that universal thinking or universal guiding principles to help us design catalytic activity, either enhance the activity or reduce the catalytic activity. So we're going to look at a number of reactions, for example, oxygen evolution upon water splitting. We're going to look at NOx oxidation, so NO is a major pollutant, air pollutant with severe health impact or consequences. And of course, it's a greenhouse gas. Right? So we're going to look at how we can oxidize or reduce NO, right, to generate essentially nitrogen gas. So this is also catalytically challenging process. Right? We're also going to look at a reaction that's relevant, which is in the lithium-ion batteries, how we can actually design the electrolyte as well as oxides using the positive electrodes, how they can actually, be cycled for thousands of cycles in our cars, for heavy duty vehicles, for stationary applications. We need essentially the batteries to last for 10 years or even more than 10 years. Then the electrolyte and the oxide need to be stable. Right? So how we can minimize the reactivity between essentially the organic electrolytes as hydrocarbon-based molecules and minimize the reaction with respect to an oxide surface. Right, so we are focusing on transition metal oxides free of precious metal. Right, so essentially, if we want to generate.
الو السلام عليكم. لحظة بس بدي سكر ليش مش عم يطفي معي؟ I want to. اوكي ايه فاطمة، انت اي كورسز كانوا عندك مشكلة؟
Hello, can you mute yourself, please? Hello.
Please mute yourself.
Yeah. Sorry, Prof. Yang.
No problem. So
yeah, you can wrap up by 3 minutes, Prof. Yang, so that we allow the audience to ask.
Excellent.
Thank you.
Yeah, so I think this is really the challenge and the opportunities to think about how we utilize electronic structure to design catalytic activity. So for example, so this is essentially one example how we can change the electronic structure of oxide, in particular, looking at how we can look at the Fermi level of oxides relative to the oxygen P band center, right? So this is a typical valence band center consists of metal states and oxygen states. So if we can lower the Fermi level into the oxygen P states, and you can see we can increase the surface exchange kinetics by many order, 6 order magnitude. As well as in the basic solution, we can actually oxidize water of OH minus ions to evolve molecular oxygen over a 2 order magnitude. And clearly, by changing this oxygen P band center, we can significantly enhance its catalytic activity. And utilizing this principle, we have developed a record-setting catalytic activity for oxygen evolution based on this bismuth strontium cobalt oxide. Right, as shown in this curve on the left, this pink curve essentially has lowest overpotential to catalyze oxygen evolution and give rise to essentially the minimum energy loss. This is just one example how we can utilize the surface electronic structure to enhance catalytic activity. And the second example I want to show is that for NO or NO oxidation, and similarly by controlling the surface oxygen P band center, we can also control the binding of NO on the oxygen site. And through the binding, controlling the binding strength of NO on the oxygen site, we can also control the surface speciation, or how strong, how much NO can be bonded to the surface as reviewed from ambient pressure XPS measurements. As you can see that as we increase essentially lift up oxygen P band center, we have more NO absorbed onto the surface. And with more NO onto the surface, essentially we have lowered the barrier that convert NO from left-hand side to NO2 on the right-hand side. Essentially, when you have strontium substitution of 0.25, we achieve the highest catalytic activity. And this is also shown experimentally that with a strontium of 0.25, the substitution, we achieve the highest catalytic activity. And to our knowledge, this is one of the highest catalytic activity for NO oxidation for non-precious metal. So as a time is short, so I want to wrap up and give perspective. I think is really exciting future for this area. So traditionally, I show you examples how we do research is based on human-centered scientific discovery. We have a hypothesis, we select a series of these candidates of oxides or material we want to study, and then we establish a trend between the function, like the catalytic activity, as well as its electronic structure. We can do this, with ion conductivity as function of, for example, like say phonon structure, right? So based on essentially our knowledge and hypothesis, our intuition, we develop a small set and we develop a correlation through which we utilize understanding to design new materials. And I think the future is exciting that we can essentially leverage AI and machine learning and high throughput experimentation that can increase the base, the library, the sizes of our system that we study, and that can potentially allow us to accelerate discovery of processes and materials, because this can overcome our human bias in the selection of materials and leads to unprecedented or surprising results. So typically might be eliminated through our physical intuition or human bias of selection of smaller database, right? So this is, I think, is very exciting. This is one example of a team that we're working with, combining machine learning, AI, and robotic sample preparation and testing allow us to be able to increase the output of experiments by 2 orders of magnitude, and leverage with the computation from molecular dynamics all the way to machine learning, as well as connecting the computation to experiments to aid us to essentially accelerate the discovery of ion conducting materials. So I want to essentially end to say there's a lot of opportunities and also challenges in terms of working on processes so we can decarbonize how we make chemicals and fuels materials. And there's just a few examples of how do we capture CO2 through negative emission technologies, how we can essentially utilizing new processes to make building materials, and how we can essentially recycle plastics and making ammonia. So I want to essentially briefly thank the people I work with and funding agencies and collaborators. And we believe working in diversity or diverse background is really key to accelerate our scientific discovery, and also is a key ingredient of a scientific discovery. So thank you so much for your attention.
Thank you so much, Dr. Shao-On, for the excellent talk. We have time for a couple of quick questions now.
Yeah, Dr. Hafsa, if you allow me.
Please, yes, please.
Thank you, Prof. Thank you for your impressive presentation. Really, it's a very nice presentations. And talking about decarbonizations is very important things within this global climate change. I would like, if possible, to ask you regarding the hydrogen, when you talk about the hydrogen as an energy carrier. How we can, I know that if we want hydrogen as an energy carrier, that it should be, or we can produce it here as in this slide from solar or wind. How about the economic aspect of producing a hydrogen from the renewable energy to be energy carrier? Another thing about the storage of energy of the hydrogen, I believe it's to some extent it's have a problem with the storage. So can you just explain this point, please?
Absolutely. So that's a great question, right? So essentially, this is where I think is really the challenge. And if we can actually draw an analogy and think about the use of batteries in electrifying light-duty vehicles and over time, right? So the cost of lithium-ion batteries, right? At least the system cost of lithium-ion batteries has dropped over order magnitude in the past decade. And really 20 years ago, I think the word on the streets are lithium-ion batteries are too expensive to electrify for electric vehicles. And I believe I see trends similarly in electrolytic right, in making hydrogen, right? So traditionally, for electrolytic process, we think about the cost of power, right? So typically, if you think about PEM, proton exchange membrane fuel cells, proton exchange membrane electrolytic cells, the cost is on the order of, let's say, $2,000 per kilowatt. And there are various, investment and as well as leading companies have very ambitious trajectories to reduce the cost by 2025, for example, to something like $400 per kilowatt. Right. So we are also looking at really steep, drop, a decline in the cost curve as demand increases for these electrolytic cells. Right. So I think that's really the number one, right? So how do we reduce the system level cost? Right. So I think there's a lot to learn to go as demand increases. Second, if we can make the catalyst more stable, right, and also we reduce the catalyst loading, and we essentially reduce the cost associated with the electrodes or the cost of the catalyst, that can also contribute to further reduction of the cost of systems. So fundamental research on the components of the electrolytic cell, that's really important. On the other hand, if we reduce the system level costs, right, for the generation of hydrogen, we also have the transportation as well as the storage. And so this is, I think, is again, from a logistic point of view, I'm currently working with some researchers at MIT Energy Initiative, looking at technical economic analysis and what scenario, right? So let's say, maybe in the Mid-East or New England, we have a very different scenario, right? So, and of course, also as well as in Northern Africa or Europe, right? So each region, right? So the local energy infrastructure is different, and we're looking at and we're analyzing the energy system, what type of transport of hydrogen, whether it's liquid hydrogen or other form, can be most economic. And I see there are great opportunities today for utilizing and transporting hydrogen, even at current price.
Thank you so much, Prof. Really, it's very impressive. I think the hyper system also. When we talk here, I saw your presentation here, we talk about the hyper system, and you are connecting here the power and the building. What is the criteria of doing this, or how we can use this part in decarbonization?
Absolutely. So when I mentioned the hybrid system, is really think about batteries, which is a closed system, coupled with the open system, which is essentially coupling with, let's say, an electrolytic cell or coupling with a fuel cell, right? So think about it. For example, even running our electrolytic cell, right, electrolytic plant for utilizing solar or wind. So when we don't have, wind, right? So sometimes we may not have wind for 2 weeks. And what if in the evening if we want to reduce the capital cost, right, of the electrolytic plant, essentially we need to have the electrolytic cells running continuously, right? So therefore, even we think about electrolytic plant to generate hydrogen, where the techno-economic analysis have shown that one needs to have a significant battery power essentially in the plant to enable to store the electricity, so that we can actually continuously power these electrolytic cells in the evenings and when there's no wind.
Yeah, it's amazing. Thank you so much, really, for these presentations. If we allow me, I can just also add, or just questions. The other thing also, if we talk about for the PV, for example, the solar, we have the two types, which is the thermal and the PV. For the thermal, we have already the low or the thermal storage system, which is low. For the PV, as you said, now still we don't have, so we go to the batteries. What do you think about the flywheels or another storage type of storage, such as mechanical? I think one of the things that it can be think about it, especially for the wind and the PV, since we cannot, or the batteries to some extent considered expensive. As I said, we can go for the mechanical one, which is the flywheel. It is still, I think, thinking about it for itself. So it's do feel this one is can be done, or it's have an open access to it?
Yeah, so that's a great question. So this is something that I'm not an expert of flywheel, but my understanding is that flywheel technology, generally relative to lithium-ion batteries, store essentially less energy per unit weight.
Yeah, but it's a big size, I think. Yeah, but it can be something that we can think about it later. For example, remote area. It's not. I didn't work in this one too much, but I was just starting to think about these things. Another alternative of the chemical one, which is the mechanical. So hopefully this one, it's hope it can be add something later, inshallah.
Absolutely. So I think that really if you really think about, if we electrify light-duty vehicles, that can, let's say, essentially eliminate, the CO2 emission from the tailpipe, which is, 80% of that CO2 emission from the lifetime of the vehicle. Then we have this still CO2 emission from aviation, heavy-duty vehicles, and then these essentially, as well as buildings and the industrial process, these is really to deep decarbonize. We need energy carriers or energy that is low cost, right? And that's where this really I think coming back, it is how can we store more energy, right? And with low cost. And this is where the energy carriers that comes in, into play, right? Because if you generate a large amount and think about at scale, the cost of these hydrogen-based energy carriers can be advantageous, right? So I think flywheels, I believe they can play an important role in some applications, and I think it will be interesting to explore. I will be becoming the lead editor for a new journal from American Physical Society. It's called PRX Energy. Right, so this is where the American Physics Society is embracing energy, and we think about contributing to the development of different energy technologies. And they think it would be really interesting to look at this more broadly, mechanical energy storage as well as chemical storage, and how to think about various use of the different mechanisms of energy storage.
Thank you so much, really. We appreciate your present with us. Thank you so much, and looking forward to hear from you more and to collaborate with you in this result. Thank you so much.
Thank you so much for these really awesome and excellent in-depth questions.
Thank you, Dr. Shao. I see actually great potential here for future collaboration. Obviously, Dr. Bisharia is very interested in your work, and it's an excellent talk. And we enjoyed excellent presentation from the top researchers in their field. And now we will move on, and Dr. Shema will take over, and she will be introducing, or she will be doing this next session. Dr. Shema is assistant professor in graphic design and multimedia program, and she is a faculty of Fine Art and Design College. So Dr. Shema, please, floor is yours.
Thank you, Dr. Hafsa. Assalamu alaikum wa rahmatullahi wa barakatuh, everybody. As my colleague introduced me, I'm Dr. Shema from the College of Fine Arts and Design. I'm very proud to be a member of the University of Sharjah Women Research Committee, and I would love first to take the opportunity to express my gratitude to our guest speakers for their wonderful contributions, and to my colleagues who have been a pleasure to work with to make this forum happen in the best way possible. So thank you everybody for this opportunity. The idea of the Women in Research Forum was born in 2019, just a few months before the COVID-19 emerged and transformed our various aspects of our lives into digital formats. Last year, the forum was held successfully online, accompanied with an online exhibition for the research proposals submitted to the forum. This year, the forum received large number of research proposals and entries, almost 208 proposals in various disciplines in computing, engineering, sciences, the industry, health sciences, medicine, pharmacy, and other related humanities fields. As we are still working online and we are still experiencing this pandemic, we decided this year to present the accepted research projects through digital formats. The first one is a booklet divided into 2 volumes. Volume 1 will include the first category, including specializations of computing, engineering, sciences, and other related fields. And Volume 2, that includes the entries from the dentistry, health sciences, medicine, and pharmacy specializations. Both volumes will be available soon on the University of Sharjah websites and downloadable for your records. For now, I would love to invite you to watch the video that presents the entries from the first category, which is the computing, engineering, sciences, and other related fields. I would love now to introduce my colleague, Dr. Wajdan Ben Isa, an associate professor from the College of Health Sciences, who would introduce the jury of the forum. Dr. Wajdan, the floor is yours. You are muted.
Thank you, Dr. Shaima and the team. It's really a wonderful forum. And I think we're coming to the end of this forum. We mark the success, inshallah, of this forum by announcing the winning projects that are submitted to this forum. As you might, we would like to remind you maybe with the aim of this forum, which is to enhance the role of women actually in scientific research and innovation, to encourage and motivate women to continue in the field of scientific research by presenting women's achievement in various fields of scientific research at the University of Sharjah. The forum included many research awards in various fields that address the most important topic and urgent and priority research challenges in the field of scientific research. Also, we would like to remind you that there are two categories for submitting, if you remember. We have one for scientific research for female graduate students and another one for female faculty members and researchers. I think we mentioned this information very many times because it's very critical and mark maybe the success of our effort. We have a total of 208 researchers submitting from 26 universities across the country. We have submission from 68 countries, 68 research papers from 15 countries. And also, we would like to emphasize that all papers have been reviewed thoroughly and critically by 3 reviewers. Also, if we are looking at the categories here, this is the distribution or the detailed submission. You can see that engineering has the largest number of submissions with 54 projects submitted for only these categories. And also, we have a total of 26 universities. These are distributed between public universities and private universities. Now, is everyone ready to announce the winners? All the projects are winners, but it was very challenging decisions to select the winning projects based on certain scores given by the reviewers. We will be now announcing the winning projects for the category number 1, which is the engineering, computing engineering, sciences, and other related technology, law, business,
humanity, etc. Dr. Wajdan, I would like to make more suspense and more moments for waiting for the announcement for the winners. I will ask all people to open the camera.
Yes.
Before we announce the winners of today, and I agree with Dr. Wajdan, all of you are winners. Putting a research application and put it forward in the first round and then in the second round to be reviewed by 3 reviewers, that's by itself is an achievement. We will give you a certificate of recognition for this participation, and we really wish to continue of what you are doing. You're doing great. And before announcing the winners, we want a group photo. We have 26 universities participated in this forum, in this platform. This shows high potentials of our females, that they are doing a great job in the research in different fields, as Dr. Wajdan, she mentioned plenty of fields, and we have 14 prizes. But this is a great reflection of what we are doing. And hopefully by next year, this platform will be even extended to have other female researchers outside the country. So I will stop sharing with the hope to see the open cameras. Put your hijab if very quickly, do your hair very quickly. We would like really to have a group photo. We'll give you a minute to have this group photo. We emphasize to make this moment part of our history of this forum.
Yes.
I think our picture will work, Doctor.
ما في مشكلة يا دكتورة خديجة، ما في مشكلة، كله حلو، كله حلو. نورتينا. If you are able to open the camera, that would be amazing. And Bayan, she will be taking a screenshot very quickly. We will put it as a gallery view. I can see bright ladies. Allah, Allah, Allah. Beautiful ladies. Seeing you with this very wide smile. I can see that you are proud of yourselves. I can see that you are coming from different backgrounds, different universities. Your universities are proud of you. You are being really our ambassadors. We have a message, we have a mission, and we are all together. We need to work really hard to have the reflection that women can do magic in any field. And the proof is here. You see and try to scroll it. Put it in a gallery view, scroll, you will find there is 9 pages. If you scroll, you will find a big number of ladies. And I'm sure Bayan now she's taking a screenshot. And I can recognize, I can recognize most of you are in the booklet. MashaAllah. And this number will be increased by next year. These are really impressive, very delightful, very proud. My heart is now really beating very strong because I can see that this platform is highly needed, very needed, because this platform is where we really come together, share experiences, making sure that we are on the right track, making sure that you are not only one. Sometimes you feel you want to quit, sometimes because of the family responsibilities, sometimes because of the high load of teaching, sometimes because of the so many in your plate. But this platform, you can renew your intention, hearing the successful stories as you have heard it from several female speakers today. It is fabulous. That shows you that you are able to continue without quitting all the excellent work you're doing. Amazing. You are really ambassador and you are really making great job. We are very proud of you. And this platform, we would like to see you every year in this platform so that we can celebrate together all the achievements. And I will not exclude our men colleagues. I can see them also in our list. You can be part, of course, of this photo because our male partners are always needed. Don't you agree? Raise your hand.
Oh, yes, I agree.
Definitely. So the screenshots are done. Back to the slides. And thank you, Dr. Wajdan. You can introduce now Dr. Fatima.
Please.
Yeah.
Dr. Wajdan, thank you, Dr. Shaima, for this informative presentation. And now we have reached the crucial moment of the conference, and everyone is waiting for the announcement of the winners, the names of the researchers that who won the conference award, which amounts to 10,000 dirham. Before announcing the names of the winners, I would like to remind everyone, each participant in the research.
Can you mute yourself, please? Can you mute yourself? We're almost there. I know it is a long day for everyone, but this is the critical moment that everyone is waiting for. Hi, Dr. Fatima.
Okay. Before announcing the names of the winners, I would like to remind everyone that each participant with the paper or the research in this conference is a winner, as all researches were valuable and useful. I will announce the winners of the first category only. Category 1 includes computing, engineering, sciences, and other research related to technology. Dr. Wajdan will announce the winners of the second category for medical, dentistry, pharmacy, and hair sciences. And before I start listing the names of the winners, I apologize if I misspelled some of the names. And I recommend you to keep your eyes on the PowerPoint slides to get to know your names. And perhaps you will love the names that you hear more than your real names. Who knows? So starting by the winners in the first category, computing is the first category. The first group of winners in the first category, computing, are Reem Al-Fatih Salman, Ayman Al-Zaatra, and Hannah Suleiman from American University of Sharjah. Congratulations.
I hope they are with us.
Yeah, hopefully they are with us.
Yes, yes, we are. Thank you so much. This is great.
Congratulations.
Absolutely great. I'm so
Mabruk.
happy. I'm so happy. Thanks. Thank you. Thank
Thank
you.
you.
This is really great. I really appreciate it. Wow. Great.
Okay. The second group of winners, also in the computing category, are Tetiana Habuza, Nazar Zaki, and Yuhin Statsenko from United Arab Emirates University.
Yay, thank you very much for
Congratulations.
this. Thank you. Hopefully you can hear me. It's highly appreciated. Yeah, I'm very happy to hear that.
Yes, this is your
Hopefully
proud
we'll-
moment, I think. Yes.
Yes,
Tatiana, she did an excellent presentation yesterday
thank you.
conference. I
Thank you.
attended your presentation. You are a true female researcher, PhD student.
We would love to see her picture if it's available.
Amazing.
Thank you very much. Yes.
I was
Yeah.
afraid that both awards here and yesterday. I was afraid you take two awards, Tatiana.
Thank you very much.
Proud of you.
Hope to hear from you and see you face to face. I'm really waiting for this moment happening. Thank you again.
Congratulations.
It's an honor.
Excellent job.
Thank you.
So we continue.
Yes, please.
Coming group of winners are in the engineering category. They are Jawahir Al-Yammahi, Rambabu Krishnamurthy, and Fauzi Banat from Khalifa University.
Anyone here with us?
Thank you. Thank you.
مبروك مبروك جواهر.
الله يبارك
Congratulations,
فيكم.
Jawahir.
مشكورين مشكورين.
You deserve it.
Will you give something to your supervisors?
Of course, we work as a team.
Inshallah.
Inshallah.
Okay, the second group, also in the engineering category, are Julie Shishuan Liu and Yi Fang from New York University, Abu Dhabi.
Thank you so much. I'm really honored to be here and to have this award. Thank you so much.
Congratulations.
Julie, please, how we pronounce your
Bravo,
name?
bravo, Julie. Bravo. Thank you so much. Excellent work.
Much for this appreciation. Thank you.
Julie,
Hi. Yeah, thank you so much.
how do we pronounce your name, please?
Yeah, you did it perfectly. It's just Qishuan.
Sichuan, okay.
Yes.
Okay.
One. Okay, that's the one difficult one.
Yeah,
Thank you.
The most difficult. Okay. The third group in the engineering category, always we have three groups in the engineering category who won the prizes. Zakiya Begam and Mohammed Abdullah from University of Sharjah. Zakiya, Mohammed.
Anyone here? Anyone here, University of Sharjah?
Zakiya.
Hello. Yes.
Yeah,
I'm
she's
here.
here.
Mabruk, Zaki.
Mabruk, Zakiya.
Thank you very much. It was an honor participating in the forum. We are happy it was a teamwork. We really appreciate this initiative.
Thank you.
Well done. Thank you. Well done. Congratulations.
Okay.
Mabruk, Zakiya. I know you're an advisor. You have an excellent advisor who empowers women.
Yes, I do.
Let's go with the Now the sciences category, we have the group winners name as follow: Fatin Samara, Sandra Knutson, Tala Abdullatif, and Sarah Muhammad Al-Abdallah from American University of Sharjah.
Thank you very much. We really appreciate it. It was wonderful to be able to work with the Sharjah EPAA on this as well. Thank you.
Congratulations. Now I announce the winners in the others categories related to technology. We have this group of Afra Al-Hamli, Carlos, I think, Mertazanis, and Ilyas Kampuris from Abu Dhabi University.
I will stop for a while because so much excitement make the PowerPoint frozen.
Oh, it looks like the energy is spreading around.
Yes.
The energy is spreading around.
Yeah. I will open it again, please. Yes. But you already announced.
Last slide in this.
You want me to share it, Dr. Manar?
No, I have it. It will be science category, right? That last slide for that. Yes. I'm sharing it now.
We finished with sciences category.
Yeah, the last one. The last one is the most sweetest one. We always keep you in suspense.
Yeah.
Okay. I think it will. It's a few seconds. It will appear now.
Yeah. This one, I think, is for the second category, this slide, which appears.
No, it is the first one, the science.
There is one for Fatin. You did not announce.
Yes.
Samara, yes, we finished it with this.
I think Fatin Samara also.
Yeah, we finished it. And now this one, Dr. Fatima.
Yeah.
Yes. In the category of sciences, we have Rimya Rada and Dr. Muhammad Hussein Al-Sayyah from American University of Sharjah.
MashaAllah, American University.
Yeah,
they get more prizes.
Oh, yeah.
Rimya or Dr. Muhammad Hussein, are you present?
Rimya, are you there?
We're here. Thank you very much.
We can see the man who empowers Rimya.
Thank you. We appreciate it.
Thank you, Doctor.
Thanks for your support.
Thank you. Mabruk. Congratulations.
Thank you.
So now the others categories, we have, I announced it already this slide, Afra Al-Hamli, Kalios Mertazanis, and Ilyas Kampuris from Abu Dhabi University.
Yes, here we are. We would like to thank you very much for this wonderful award and for your appreciation of our own work.